Okay, so this is the second video now, and what we're going to do now is create our game engine as a dynamic linked library, or DLL. And once we've done that, we can then use it in more programs than one. The idea being that if you want to create multiple games from the same game engine, you can if you have time. So what we're going to do now is we're going to add a new project into our solution. So we're going to go to Solution Explorer. I'm going to pin it on the screen for now. I'm going to click on the top line where it says Solution, My Game 1, right click, Add New Project. Now this time we're going to use something called a class library, and I'm going to call it Game Engine, all one word, and just hit the OK button, and straight away it comes up with a brand new project with this class1.cs. Now we're actually going to delete this class1.cs like we do with everything else, because we're going to set it up from scratch. But we need to make a reference, so we need to tell this program, My Game 1, that we're actually going to use the game engine as part of the program. So we right click on My Game 1 and say Add Reference. This then comes up with our projects list, and we can see that the game engine's already highlighted. We just hit OK, and you see now game engine is one of the references within the game. And what we're going to do is we're going to close down our menu. We don't need to play with that at the moment, and we're going to open our game form. I'm going to right click on the game form and hit View Code, and all I'm going to do is add to the end using Game Engine. Now at the moment there's nothing inside the game engine that we can use, so I'm just going to save that and leave that as is. What we're going to do now, you see, is right click on Game Engine, and we're going to start adding some of the classes that we need to add. The first class we're going to run is something called Basics. This is going to be used to set up our entire environment. We're then going to right click again, add another class. Now the elements that make up our game engine are, first of all, the background. We're going to need a background. The background is actually sandwiched with multiple backgrounds on top of each other to create something called a parallax scroller. So we're going to build something called parallax, spelled P-A-R-A-L-L-A-X. There's our class parallax. We're also then going to add a camera object. If we don't have a camera in our game, we won't be able to actually work out where anything is, because we won't be able to see anything. We also need objects in our game, so I'm also going to add a class that I call GameObject. So we have a background, basics, camera, GameObject and parallax. We're also going to want to do animations in our game, so I'm going to create something called a graphic object, which is used to develop animations. Finally, we need to put all of this into a single location, a single world as it were, so I'm going to create something called a game world. Once I've got all of these and everything's all saved, I'm going to go to the build on the menu, build game engine first of all. Once build succeeded has come up, I'm going to click on my little tab, go back to FRM game, and you can see that the red line has now disappeared from under game engine. And we'll be able to use this to create things like a game world. As you can see, game engine dot, and I can find what's possible inside there. At the moment we've not created anything within our DLL file, so there's nothing that we can do. I'm going to start with the basics for you guys, and I'm going to obviously have to explain a lot of what I'm doing as we go through. So I'm going to close down my toolbox, and I'm going to close down Solution Explorer first of all. Now the class that's within here we don't actually need at the moment. We're going to create our own classes. So the first thing I'm actually going to create are some structures. We have to use the keyword public because we need to be able to see this within our game form itself. And I'm going to create a struct called point3d. A struct is a special type of variable. Basically it allows me to have lots of variables inside each other. In the software we've already created, or you may have already created, you may have already used a point variable. A point variable, which I can't show you here because I haven't got the right usings at the top yet. I thought I would have, but I haven't. A point variable has an x value and a y value, which are both integers. It's useful if you're doing things in 2D, but our game engine is going to have a third dimension associated with it in case we use the 3D projector. So what I'm going to do, I'm going to recreate the point structure, if you like, but as a 3D item. So we're going to need 3 different values, x, y, and z. An x value, a y value, and a z value. Now we can create something called constructors for these. So what we say, we write the word public and then the name of the object, point 3D. We use smooth brackets to create our 3 initializers, as they're called, so we can set an initial x, y, and z value if we wish. And all we have to do is set x to equal x, y to equal y, and z to equal z. How does it know which one's x, y, and z? Notice that we're using uppercase letters in our actual structure and lowercase letters within the initializer. Now it may be, because of the way that we're going to have things stored in a level file, that it'd be actually much more useful for us if we had strings instead of integers as our initializers. So I'm going to change my x, y, and z lowercase to strings. And then what I'm going to do is tell these to convert to int32 x, y, and z. So this way we can actually initialize our 3 variables using string values and turn them into numbers. Okay, so that's our first object, public struct point 3D. Because we're doing some items that involve parallax scrolling, we are actually going to be doing quite a lot of decimal maths involved, so we're going to need more than just integers. And I'm going to use x and y values for this rather than x, y, and z, because our screen is actually 2-dimensional, obviously. So what I need to create now is a structure which is like the point. It has an x and a y, but it uses decimals. So I use public again because it's going to be seen by the form. It's another structure that we're going to create. Ooh. If I can spell today. And I'm going to call this one decimal point. And this one has a very simple structure. Public decimal y. So it has an x and y value. If I want to add an initializer, I can. You don't have to. Going through all the code that I've been through, I haven't needed an initializer just yet. But if you want to add one in, it's your choice. I'll put one in for you to be able to see how to do it. So in exactly the same way as we did before, we can have decimal x, decimal y value, x equals x, y equals y, and then you've got yourself an initializer. Notice all of these are within the namespace game engine. So I'm just going to go to the end of each one of these structures. If you want to make a note, you can use comments, /. This is a 3D point structure. As I say, I can't spell today. This is a point using decimal numbers rather than integers. So what else do we need? Well, we might need to be able to store the actual size of an object in 3D. Now size exists as a structure as well, but again it's only 2D. So I'm going to create my own size 3D structure. And again it's going to have public int. This time I'm going to have a width, a height, and a depth, except I can't spell. There we go, that's better. Notice that start and end curly brackets. Make sure you put these in yourselves. Okay. As well as these structures, which are going to form the basis of our game engine, we're going to need something called an enumerated type. Enumerated type is a way of being able to have use numbers and use words in the place of those numbers. That's not going to make any sense whatsoever. Let me give you an idea. Say I've got up, down, left and right, and up is 0, 1 is left, 2 is right and 3 is down. I could remember all of those if I wanted to in my code, but it's very hard for a person reading the code to remember what a 0 means where and everything like that. So instead of doing that, I can use these things called enumerated types that are basically a list of different items, and each one represents a different value. What I'm going to do here first of all is the different types of cameras as an example. Okay, so I'm going to create my own enumerated type. You start public again, enum means enumerated type, and I'm going to call it camera type, and I'm going to give it 3 different options. So inside the curly brackets, standard, which is a normal camera. If it's going to be a 3D camera for the left eye, it's going to be called left 3D, and if it's for the right eye, I'm going to call it right 3D. Notice there's no need for a semicolon on this because it is a list of items. The graphics on the screen I might need to scale at some point, which means that I can make it bigger or smaller. If, say for example, you've got a zombie game and the zombie's going to come from the distance and going to come towards you, you might want to scale them downwards and upwards as you go along. So what we're going to do here is we're going to create another public enumerated type, and I'm going to call that graphic type. And the types of graphic that I'm going to have are standard again. We can scale along the x-axis, scale along the y-axis, scale along the z-axis. So that means as the z changes it scales, as the x changes it scales, as the y-axis it changes. We might want to scale along 2 axes, so scale x, y, scale x, z. Notice there's no spaces, you're not allowed spaces in your names. I also might want to scale no matter where I move my character to, so as the x, y and z values change I might want to scale it. The next thing I'm really going to need is an enumerated type for colliding with the sides of the walls. If you imagine my mouse cursor is a character, when I hit a wall I want to know which wall it's hit. Has it hit the top, left, right, bottom wall? Say you're making Pong, you want to know that the ball needs to bounce off the top wall but scores a goal if it bounces off the end wall, for example. So the side of the level collided with. So when we do collision detection, this will make more sense, hopefully. So I'm going to create another enumerated type. I'm going to call this wall collision. And the items on this are going to be obviously top, left, right and bottom, because they're the 4 different walls that I can collide with. Okay, so I'm going to save that, and I'm going to just build my game engine to make sure everything is all saved, and build succeeded means everything's working okay at the moment. And that is where I'm going to leave this video. So what we've done now, we've created our basic structure for our game engine, and we started putting in some of the basics that we're going to need. There are some more we're going to add to this file in the future, but for now we've added a 3D point, a decimal point and a size 3D, and then we've created 3 of our lists that we're going to use, our enumerated types, what type of camera we're going to use, what type of graphic when we're doing things with objects, and what type of collision with a wall that we're going to have.